Hello everyone. In this video, I'm going to solve problem 1.16 from chapter 1 of our book. So the problem statement is first, the filament of 150 watts incandescent lamp is 5 centimeter long and has a diameter of 0.5. So he's talking about the filament dimensions here, and the wattage of the bulb is 150 watts. So the heat flux on the surface of the filament, the heat flux on the surface of the bulb, and the annual electricity cost of the bulb to be determined. So these are the three-part question, or maybe we could say four-part, because you need to find the amount of electricity per year first, and then multiply with the cost of electricity to get the so other part of the information he has given is the diameter of the bulb is 8 centimeters and cost of electricity is 8 cents per kilowatt hour. So okay, so what I did was I took that information, transferred onto my worksheet here, and so as you see, the filament is there, length of diameter is there, diameter of the bulb, and so on and so forth. So let's start with the first part of the question, which is determine the heat flux of the filament. So how do you find out the heat flux? What is the formula for the heat flux? The formula for the heat flux is Q dot, small q dot, is total heat transfer divided by surface area of the filament. So here is a filament, and the diameter is and length is given, so we just plug the values. We know it is a 150 watt bulb, right? So we put down 150 watts divided by surface area of this, because this heat is radiated from the surface of the wire, so that's what he wants, heat flux on the surface, so that is pi dl. So plugging the values, you will have 150 watts divided by pi times diameter is in terms of meters 0.005 times 0.0005 meters, and the length is the length is surface length we're talking about. I mean the length of the filament, which is 8 centimeters, is 0.08 meters. 8 centimeter converted into the meters. So the value of that Q flux would be, by simplifying it, you will come up with a 1.91 10 to the power of 6 watts per meter square. Always remember, the flux is per meter square, so not meter cube, it is meter square. So because it is radiating from the surface of the wire. Let's go over to the second part of the question. The second part of the question states is, what is the heat flux on the surface of the bulb? So the heat from here is projected onto the surface, and he wants to know what is the heat flux on this surface. So we assume the bulb to be like a sphere. So surface area of the sphere is pi d squared. So diameter is given, so surface area. So going back to the question again, the heat flux for the surface of the bulb equal to, again same equation, Q dot, whatever the heat, this wattage of the bulb is, divided by the surface area, which we talked about in this case, where since it is a sphere, the surface area of the sphere is pi d square. So we know pi, and diameter is we said 0.08 pi d square, and now we plug those values. 150 divided by pi 0.08 meter, this is 0.08 meter square here, and 150 is a watts. The simplification of that will come down to 7,500 watts per meter square. And now after that, the third part of the question is amount of electricity per year. There are two parts of the question here. One is how much the amount of electricity is being used, and the cost is a separate one. We'll talk to the first finish of the amount of electricity. We know the wattage, which is so how do you find that? So if you want to say amount of electricity, put down amount of electricity consumed equals Q, which is a wattage of the bulb, times delta T. That means time in hours, because he wanted to know per hour, remember? So delta T is, we need to find out in 1 year how many hours are there, using depending upon the usage of the bulb. So in this case we'll use like 8-hour usage, so per day. So now plugging the values, we know first of all, let's start with the wattage. So we know the watts of the bulb is 150 watt bulb, 150 watts, Q that is, and if I convert it into kilowatts divided by 1000, it would be 0.150 kilowatts, because I want kilowatt per hour. So you plug the value 0.150 kilowatts, and then multiplied by delta T. Delta T is, how do we calculate? We know in a year we have 365 days per 1 year, and if we are using this for 8 hours per day, so at least what we'll come up with is we'll come up with the kilowatt consumption per year. So by simplifying that, you will come up with the value of 438 kilowatt hour per year. So with that information, so we have total number of electricity use, and we know he has given us the cost of electricity. The cost of electricity is 8 cents per kilowatt hour. So we just, all we have to do is trying to figure out annual cost. Cost is multiply the total usage times the cost. So total usage, we came up with a 438 kilowatt hour divided by per year times the 8 cents per kilowatt, 0.8 in terms of dollars here now per kilowatt. So kilowatt gets so we come up with the we will get the value of $35.04 per year. So this is how you do the problem. And just to summarize, going back again one more time, So first he wanted to find determine the heat flux. The equation for the heat flux for the filament is, because we need to know the surface area, it is the heat is radiating from the